you can
Great.
go.
Okay, well, if you've been to one of my presentations before, you know I almost always run long, and there's no lunch after this talk. So I'm just going to start immediately. I will try and go quickly, and I will actually stop on time if asked to, which that is a gift from me to the community. Okay. I decided I was going to do this whole talk in my terminal. This seemed like a good idea at the time, and at this point, there was no other option. So I've produced some slides here. There we go. All right, let's cat them the other way. Okay, so we're going to talk about how to debug Perl. This font's it's a little small. Let me. Oh, well, that's worse. Let's downgrade these slides a little bit and try them in Vim. We're going to talk about how to debug Perl. I am Rick. I'm RJBS. I work at Fastmail. I have written a lot of Perl code, which means I've written a lot of bugs, and some of them I have fixed. Some of those I have even fixed with the debugger. And I'm constantly surprised when I work with other Perl programmers at how few of them, especially those who are really good programmers and write and solve more bugs than I do, don't know how to use even the basics of the Perl debugger. It's a really useful tool. I don't use it all the time, but I do use it, and I think more people should know how to use it. So the first question is how do you debug problems in Perl? And the answer to this is actually pretty straightforward. You add more print statements, right? And that's it. That's like how I debug 95% of my problems in Perl. Maybe more like 98 or 99. You add the right print statements, and you generally find the problem. So maybe I shouldn't really talk about how to debug, but rather drop the pretense and talk about how to use the debugger, because you will know when to use it for debugging when the print statements aren't going to work. 99% of the time when I use the debugger, I'm not really using it to debug anyway. I'm using it as a REPL. A REPL is a read, evaluate, print loop, which basically means the program will read some input from you, it'll evaluate it, print the result, and then do the whole thing again. So it's a way of running your program or anything you want one line at a time. You can get Perl's REPL by running Perl-DE0. It means something explainable. I'm not going to explain it, but it means start the debugger, start the REPL. And once you've run that, it's going to start asking you for input and evaluating everything you type in. There are a lot of other REPLs in Perl, specifically REPLs that were designed to be REPLs, right? Exploratory programming tools. You could, for example, use IRB in Ruby, or just run Python with no arguments, and you get a REPL that feels a lot more like you're meant to be there playing around. Perl's REPL feels like you have fallen into the boiler room. So I could talk about those and teach you how to find a really nice REPL like reply or devil REPL. But I'm not going to. I'm talking about Perl debugger because that's already everywhere and you can use it for other things. There are also other debuggers. The Perl debugger that I'm going to talk about is the one that comes with Perl, perl5db.pl. And it is maybe not the best Perl debugger. There's one called Devil Ebug. There are some other ones and they're neat, but you don't always have them. And by the time you have sunk into the depths of despair where you realize you need to use a debugger and not just print statements, you're probably not going to install these, right? You've got the debugger right there. Just get it over with. Nobody really, I shouldn't say nobody really uses them, but they're much less commonly found at the time of despair, of your time of despair. Okay, so if you're going to use this as a REPL, you want to know what stuff it can do that is REPL-y. Anything you type in, the Perl debugger is going to evaluate, and that's it. Just evaluates it. If you want to print it, you can use the P command. P will print whatever's been evaluated. X will dump it. So it'll dump out a deep data structure, for example. Q will quit the debugger. You might be thinking you can press Control D, like almost any other interactive utility, and exit the debugger, and that will often work. But sometimes you will have gotten yourself into a state where hitting Control D will start the nested debugger. I'm not going to explain the nested debugger because no one wants to hear about it, but it's what is going on when you start seeing extra angle brackets show up in your prompt. If you have seen that before, that's what happened. It was the nested debugger. Hit Q instead. Okay, so Maybe most of this talk is a live demo. So this should be exciting. We'll see how it goes. This is the REPL, right? I am showing you, one second. I am showing you the REPL. I can do stuff like, say, 18, right? That's an expression. It got evaluated. And you're like, but what did it evaluate to? Well, I know it's 18, but it doesn't print that because it only evaluates the statement, right? If you wanted to print it, you have to say print 18. If you wanted to say print hello, that's one of those cases where you end up with, well, it prints hello, but it also prints the evaluation, and the evaluation of print is true. So you get one hello. Fine. You can use X for big, complicated data structures like this one. If you print them, you get exactly what you deserve, which is that, right? It's a REPL. It's fine. I use it all the time. This is what I use when someone says, did you know that if you take a string and you add 13 to it, it reverses the string? And you say, no, it doesn't. That's ridiculous. And then you fire up the REPL and test it, and you find out it's true. It's not true, that one, but most absurd things people will tell you about Perl 5 are actually true. Okay, so how does this work? There is a variable in Perl called $P, and that is the debugger stuff. When you run Perl with -d, it turns on a bunch of bits because that variable is a bit field. And you can see what all the bits mean by looking at perl-v for that variable. And it's really interesting and you can learn a lot, but I advise you skip it. The key flag here is the bit for 2. And that turns on an instruction to the Perl runtime that says, every time you're going to evaluate a statement, call the subroutine located at db::db, right? This is what the debugger is, in a sense. It's that plus some other magic variables. So you could write something instead of Perl 5 db, you could write your own debugger. And the stupidest debugger you are likely to find is a great piece of software called Devil Trace. It's on CPAN. And it basically looks like this. It says db means every time you're going to run a statement, evaluate this subroutine, call this subroutine. It's really nasty looking. It says, get the stuff out of caller, right? The package name, file name, and line number. And then there is a variable, bear with me. There's a variable that is at : _ left angle bracket file name for every file name your program has loaded if you are running under the debugger. This is actually as bizarre as it sounds. I am not embellishing. It's really that weird. The indexes in that array are line numbers. And if you want, you can get index 17 out of any file you've loaded and you find the source. So this little debugger, tracer, whatever you want to call it, every time it's about to evaluate a statement, it prints to std that it's about to run the line, right? The piece of code found in that file at that line, as well as what line and file it was. If you run a program with this loaded, you're just going to see every line of the program printed as it gets run. And that's how the whole debugger system basically works. Perl 5 db is a really, really complicated db::db routine that lets you muck around with what's going on every time you're about to evaluate a statement. So d::trace turns on a bunch of flags in $P and loads Devil Trace, which sets up the db subroutine. If you don't pass any argument to -d, it loads perl5db.pl, the name giving away how ancient this piece of code is, and it sets up the same variables. Whatever, yes, this is very true. Whatever you do, don't read that code. I have read that code. It had effects on my life that I could not predict, and I would not wish them on you. It's there. You can read it. It has gotten a lot better in the last 5 or 10 years, but it's a thing. You can read its Perl doc. That's not so bad. It explains a lot of things. Perl doc, Perl deb guts is also pretty good. And Perl doc, Perl debug is probably where to start for getting, how do I even use this thing? Or you can keep listening to me talk. Okay. Let's step through some code. Here are commands that you're going to use to step through an actual program when you use it to run a program instead of just to be a playground for running your Perl one line. N always evaluates the next statement in your program, right? So you've begun running, you're going through the program, N will run the next statement, the next one, the next one. S steps down into the next statement. So instead of just evaluating that statement, it steps into the next part of evaluating that statement. So if you've got subroutines, it won't just tell you the return value, it will go down a frame into the subroutine and start debugging in there. C is going to continue running your program until it's over, or unless there's a breakpoint, which we'll talk about later. But a breakpoint just says, if you were continuing to run a program, stop here. And if you just hit enter in the debugger, it moves the same way you just did, right? So another N, another S, or another C. There's also T, which will trace through an expression, which basically means print everything you do as you go. I find T very hard to use, so I'm not going to talk about it, but it's there. Be aware. Let's talk about a real program. This is a beautiful example of some high-quality industry-grade Perl. This is a cryptographically secure random number generator. I can assure you it does generate random numbers for some definition of random. It's about the simplest one I could produce. It takes a couple pieces of configuration, some state, and it produces a pseudo-random number generator every time that you call that routine. Right? And that routine has a state variable, which means every time you call, you're getting the next pseudo-random number in the sequence. And what does it do? Right? This is the generator. Oops. Oh, that was surprising. That was the generator. And this here is going to say, get a new random number. And every time you get it, print it out. And if it was 1, you're done. Stop at 1. So what you'd expect to see is it's going to start spitting out a whole bunch of random numbers until it says 1, and then the program completes. That's what should happen. So what actually happens? If I run that program, it exits. All right, it's not doing anything. I didn't get a single random number. It couldn't even have put out 1. Because I have a print statement. I mean, adding print statements is my strategy of first resort. There's 1 right here. So it's not even spitting out a 1, because if it was 1 on the first go round, you would have gotten a 1. So what are we going to do? Let's debug it. So we can use the debugger to open up this program, and what happens? We started the program and we hit C, right? C is continue running. Well, nothing, right? It runs to the end. That's what C does. So let's start over. We know that what's going to happen. We've continued running this. Let's say this. We've run this program. It didn't work. Maybe random isn't working, right? Maybe we're not getting the value we want out of it. So I can call random, right? Calling random is an expression, and I'm going to dump the output from it. But what do I get every time I do this, but a beautiful sequence of pseudo-random numbers, right? So why didn't this work? Let's start over. So we start the program over. Here we are. This is telling us the next line that's going to be evaluated. It's going to evaluate while my I equals random. And if we say next, it's going to evaluate that, and the program's over. Okay. So that didn't help. So let's start over and say step. All right. Step is going to say, don't just evaluate this statement, step down into the subroutine that's in it. And now what do we see? It says you are now inside of main random, subroutine random. And this is the code that's about to be printed. Okay. I mean, I don't know what's wrong with the program yet, but we could do some stuff, right? We can say, what's in X? Nothing. The reason there's nothing is that it shows you the statement before it evaluates it. So if I want to see what actually happens when I evaluate this, I want to say next, and now it shows me the next line that we're going to see. And now if I examine what's in big X, I see 10, right? Because it evaluated the assignment of 10 into X. And I can go past a couple of these, and if I want, I can look at them, you know, what's in A, what's in M, what's in C. You will notice, by the way, when I examine a simple number, I get 2 bits of output. One is 0, and one is 21. 21 is obviously the value of the variable. You're getting 0 because the dumper is taking a list of things, and this is showing you the index into the list. So if I was going to say, and I hope this works the way I recall that it works, yeah, if we examine a list of things, we get item 0, item 1, item 2, and then on the right are the values. Okay. So now we get down here, and we've got this expression where we're going to get x equals this thing. So if I take this expression here, a times x plus c modulo m, and I evaluate it, we get 0. So the problem, if we go back to the program, the first time we call random, as we are now, the actual number that comes out of it first is 0, and while needs a true value. Right, so we are being bitten here by the fact that false 0 is anathema to all good programming, or maybe that foundation of all good programming. It's one of the two, from what I've heard. Effectively, what we've done is we've gone and inserted as many print statements as we needed into the program as we ran it. Okay, so this is like the very basics of step through your program and look at it as it goes, which is pretty good. If we want, we can continue running and the program fails. We can go back into the program and we can fix it, right? And the way we fix it is by adding defined. So great, we've debugged our program. We've said that we're going to add a defined here. And if we run this program, right, there's that program. It runs for a while, it gets to 1, and it stops, just like we wanted. Terrific. But this is not a realistic piece of Perl code, right? Real Perl code is modular, it's well factored, it makes sense, and it has lots of different pieces. Something like this, where we have taken that subroutine and put it into a library. So now we can use this pseudo-random number generator whenever we want. Beautiful. And a piece of code that uses it might look like this. Use the pseudo-random number generator and then call its random routine, right? This is highly modularized programming. And when you're done, as you run, we're going to accumulate all the times we saw any value. And when we're done, print them off, all the values that we saw in numeric order. Okay. If we're going to run through this program, there's some other commands you might want to use to figure out your way through the program. As programs get bigger, they become harder to navigate because they aren't just a sequence of lines. Right? Our first program was in some ways almost a basic program. It was one sequence of lines that we moved through. And sure, sometimes we jumped around, but effectively it was one sequence. Now we've broken this up into multiple files that themselves communicate with one another. L is a command that's going to list the code that you are currently looking at in the debugger. You can give it a number and say you want to look at that particular line of Perl somewhere in the program. You can say X through Y to list that range of lines, or you can list an individual subroutine and see just that sub. You can also use V, which means don't just show me the line that I'm looking at. Show me a little bit before and a little bit after the line, which is nice for figuring out some context of where you are. Also, there's dot. And dot says, it doesn't matter what I'm looking at now. I want to go back to looking at the code that's about to run. Because as you debug your program, you're going to say, I need to go look at what happened somewhere else. What is the code that implements some other part? And you kind of turn your gaze to some other piece of your operating program. Dot will say, look back at the line that's about to run, dummy, because you're going to hit next and you want to have that expression printed out first. Also, I don't know why the dot keycap is so much smaller in this typeface, but it is, and we're gonna just live with it. Okay, so let's take that program that we just ran. It's the bug fixed version of this, and we can just start off. It shows us the next line it's going to run. We can run L, right, and we start seeing here's a listing of the program. It's showing us the next couple lines of the program. If we hit L again, we see the same thing over and over. That's telling us you got to the end, buddy. There's only 16 lines in this program and you've seen them. If we wanted to see line 1, we could say list line 1. There we are. We could say list line 1 through 10. There's the first 10 lines of our program. At this point, we've basically established we just saw lines 1 through 10. So if we run L again, we're going to start at 11 and keep going, right? So you've got a kind of a moving window through the program as you look. And here we are, we're at line 13. And if I run V meaning like spread out and look in both directions, you get a little bit of line before and a little bit of line after. But then we want to go back to looking at the line that we're going to run. So we say dot, there we are. This is the line that's going to run next. And we can step through this, right? So we hit step, next, list, and you'll see what we're listing here. This is code inside of PRNG. Actually, we're looking at the wrong file, I think, but if we were running the correct file, we would be looking at code inside of prng.pm, the package. Fortunately, the code is the same. Demo makes sense. If I want to, also, you'll also see what happened is I hit Control D and I didn't exit the debugger. It's a morality tale. I still hit it too. So if I had stepped into this and I hit L, you will see we're now listing the code inside of PRNG random. So this is the package name, and this is the file, and this is the line where we're starting. Okay. All right. There are other ways to look around inside of the file. Looking around is real important. F lets you change the file you're looking at. So if you just follow the execution of the program, it will take you where you usually need to go. Every time you step, it takes you into the next subroutine that's being called, which is in some other package, and you can look around in there. But sometimes you need to go see something that's in another package. A good example is a constant, right? You need to go look up some table of constants or magic values, and you don't know what they all are. You want to be able to dump out some structure. So you go to some other file, you list through it till you see the variable or the subroutine you want. Now you know what you needed. Slash will search forward through the file that you're looking at for some pattern. C will continue running the program. We saw that a little earlier. It's useful because you can list to see the lines of your program that are coming up and then pass a line number to C to tell it that's where you want to run until. There's also T, which turns tracing off and on. And honestly, I should have deleted that because I'm not going to talk about tracing any more than that. So let's go back into this program. Here we are in the debugger. We're looking at the same old program. We can list the whole thing. And there's the program. We know that when line 8 comes around, we are going to go into the PRNG package. So let's just go look at that before we get there. I'm going to say F for file, PRNG, and the debugger is going to look for a file we loaded that seems to indicate, which is basically a substring match. So it says, great, you asked for PRNG, and I found you this file. And that's exactly the file we want. We can list this file. And if we list this file and we want to search forward for assignment for that state variable to $x, right? We say search for state. There it is. We can say V to see some context here. And maybe what we want to say is, this is the line where we've had trouble before. So we want to run the program until we reach that line. So what I'm going to do is say, continue running this program until line 11 of the file I'm looking at. And it runs and does all those little bits and it stops there, right? So this is sort of you start up with the program in the debugger. It's not moving. It's waiting for you to do something. Then you go look around, you find where you want to run the program until, and you say here, right? Run the program until you get here, and it does, and it stops. And then you can do all the stuff you want to do. Like you can say, what even is that? Great, it's 14. 14 is not 0. So I'm not even going to worry about that whole defined true problem. Okay. The way that C works is with a breakpoint. A breakpoint is just a thing you stick into your debugger to say, when you reach this point, break. And break here does not mean cause the program not to work. It means stop going through automatically running the program. I want you to stop here and let me issue debugger commands. C is just a breakpoint. When you say C11, it means put a breakpoint at line 11, and PS, when you reach that breakpoint, delete it. It only exists until you hit it once. But you can have breakpoints that don't self-destruct, that are there all the time, and you could run through the program over and over, and it will always stop there. You can add those with B. Right? So B alone says, whatever line we're looking at right now, I want to put a breakpoint there. So as we continue to run, every time you hit this line, stop. You can list all the breakpoints with capital LB, and that's going to say, I want to see all the breakpoints that are existing in my debugger. If you're using one of those fancy modern debuggers like they started making in 1992, you just see the listing of your whole program with a little icon next to all the lines. But we don't need that, right? We have the Perl debugger. You can say B7, and that's going to put a breakpoint at line 7. You can also say B subroutine and say, this is the subroutine where I want to break. So keep running the program until you get to this subroutine. You can even make it conditional. So you could say B7 condition. And that means when you reach line 7, if this condition is true, break. So this is a way to say, I don't know why this happens, but I know that when there's a problem, it's because of this condition. You stick that in, you hit continue, you walk away, and when you come back, your program is waiting for you at the correct spot. I'll give you a little demo of how that actually works. You can delete breakpoints. This is very useful when you realize you put them in the wrong place, which you always will. And you can also add actions. An action is just like a breakpoint, but instead of stopping the debugger running, it just runs, it evaluates some Perl. So you can say, whenever you get to this line, here's some Perl. And you might do something like print something out. You might send a UDP datagram because you're a weirdo. You might increment some other variable somewhere in the memory of the program so you can keep track of what's happening. You can list all the actions just like listing breakpoints, and you can delete actions just like deleting breakpoints. You can also list them all everywhere, which will be slightly interesting in a minute. Okay, let's look at how these work. So we've got a program here. iTerm is popping up to tell me that's a hot tip of the day, how to use iTerm. So here we are in our little program, and I'm going to use B to make a breakpoint at the current line. And I list, and what do we see? I've put a breakpoint on this line. This is not a particularly interesting place to put a breakpoint, but I did. I can put a breakpoint on PRNG random, right? So I'm saying whenever you get to that subroutine, I want you to break. Now, when I list all of our breakpoints, we're going to see this file, prng.pm, has a breakpoint at line 6, and it says break if 1. Remember how I said you could put a condition on a breakpoint? They're all conditional. Just sometimes the condition is true. And we've got another breakpoint here. Now, this breakpoint is not useful, right? There's no reason for us to break here. So I'm going to delete that breakpoint with B6. And now if I list all the breakpoints, we've only got that other one. And if I want to delete that one, it's on line 6, right? So I can say B6, but if I delete it, it's still there. And that's because when I say B6, it's about the file that I'm looking at now. If I wanted to go delete that one, I could either use F to switch to that file, or look, it's the only one. I'm just going to say B star, and they're all gone. Okay, no more breakpoints. Let's start over and do something a little more complicated. Honestly, I keep hitting Control D every time I want to leave the debugger, and it's like a little remember you will die moment for me. Okay, so I start this over, and we're going to say, let's look at PRNG random. So line 11, that was an interesting line, right? That's where all the hard cryptographic number theory work in this program is happening. So that's where I want to put a break, and I'm going to say break on line 11. Now, notice it told me I switched to this file, so I don't need to worry about what file I'm in. It just told me. Put a breakpoint on line 11 if x is equal to 10. So 10 is real bad for some reason. In my program, when I get 10, weird things happen. So I want to run the program until I get to 10. So I do that, and I list my breakpoints. And what do I see in that file on this line, break if x equals 10? Terrific, just what I expected. And then I'm going to put an action on line 11. So remember, an action is like a breakpoint, but instead of breaking, it just does something. I'm going to say an action on line 11, and the action is going to be say x is $x if x is not 10. Okay, so anytime it gets there, one of two things is going to happen. It says whenever I reach this file, this line, if x is 10, I will break. and otherwise I will print. Right? I will say X is 10. If I continue this, there we go. You see, it's going to say we had a 14, an 18, a 14, an 18, a 2, a 6, and then it stops. Since we stopped, it must be the case that X is 10. Hey, terrific. And if I keep continuing, these breakpoints, they stick around forever. Every time I continue, the same loop happens. Perfect. All right. If I want, I can step through this a couple times if I can keep focus on my terminal. Right, here we go. And if I have like stepped through this a few times, I don't really know where I am in my program. I can hit L, see what's going on. I can search around for, what do I want to look for? Let's say I'm going to start listing from 1. Here's the program. I'm at line 10, and I want to get into this program, and I want to run it sort of continuously. So here are my breakpoints. I'm going to clear them all. Continue running the program. Here's a problem. My program never stops. So what am I going to do in that kind of situation? If I go in here and I put a breakpoint on line 10 and I say continue, every time I continue, I end up at line 10 inside of here. And maybe the program terminates after 10,000 iterations, but it doesn't. I can promise you that right now. We know that because when we printed out what we saw every time, it was the same 5 numbers in a row. So I'm going to last out of it. So I run last. And what happened? Am I actually out of it? No, I'm still inside of here. Last, get me out of here. Huh. So we have done something wrong, and we'll have to look into that. But meanwhile, we know a way to get out of here. We're in the debugger, right? Debugger isn't just printing. When you are inside the debugger, you have the ability to change the entire state of your program. It is a terrible power that allows you to do things like, say, assign 1 to I. So when I've done this and I continue, the program actually terminates. But now I'm wondering, why couldn't I last out of that loop? What is the problem that occurred? Did I have to do last 3 times, 4 times? Were the lasts that I ran effective and assigning to I was not? We're going to look into that. And I'm going to look at it this way. I'm going to say save try last db. And what that has done now is it has saved all the commands that we ran in that debugging session to a file. And what I know is I got here and I ran last and it didn't work. So I'm just going to delete everything there, right? Here's the whole program. Here's what I ran. And I want to know why when I got there, did it get weird? So I'm going to save this file. I'm going to run the debugger again. And I'm going to load that file. This is where I realize I've forgotten the command to load this file, and that is deeply embarrassing. Yeah, it's source. It was my first guess. So what you see here is we see these angle brackets, and these are indicating to us commands that were run for us from the history file. Right? We get here, and this is where we tried saying last, and that didn't work. But what we did do was say I equals 1, and when we continue from there, it exits. So I will have a really brief digression and tell you what happened here. REPL, right? The debugger is a REPL, and a REPL is a read, evaluate, print loop. And when you type last into the command prompt, I mean, it's all just one Perl, right? Like your debugger is a subroutine running your program, and the debugger is a loop. And so when you say last, the debugger's loop sees last. And when you say last, it's kind of leaving some command parsing loop and not your program's last. Now, maybe you could say we could fix this in the debugger, and maybe that's true, but there is no maybe involved with the fact that's not getting fixed. So this is just another lesson. Always label your loops. If we were to go back into this program and add a label to that loop, it would work just fine. We would be able to last num, and it will exit correctly. I'm not talking as fast as usual, so I'm going to skip a couple little bits of slide and keep going. All right, save and source. They were right there in my slides. R will restart the debugger. So when you run R, it's basically saying, I'd like to start debugging this program again from the top. It's useful. It's especially useful when starting up your program is very slow. The caveat that applies here is it's just one Perl process, right? Like it's just one Perl and it has state. And if you are lucky, restarting the program, which basically means go back to the first line, reset all the global variables and start over. If you're lucky or very, very careful, you can know that has cleared all the state that your program might have. But if you have global variables that might have weird closures in them, or you have file handles that are sticking around some way, weird things can ensue. I almost never, ever use restart for the debugger. You can also rerun. So you can say, I want to rerun this debugging session, but I want to stop at line N. And more interestingly, you can say stop at line -N. So do everything I did except the last command, right? Rerun -1 means run everything I did, but don't run the last command again. So we've edited this file. We remove last. Now we can source this file. It gets us here. And we last num, because we labeled that loop, and the program exits. Great, except I actually wanted to do something before we ran this and exited. So we're going to rerun -1, run the whole program, but stop one line before we got to the end. And then I'm going to list all my breakpoints, delete all my breakpoints, delete all my actions, put a breakpoint on line 13, and then I'm going to last out of that loop. And then we're going to stop at line 13. All right, so this is us putting together the ability to see what's going on in the code, clear the breakpoints, set the breakpoints, step around, all that good stuff. Okay. So this just had us editing a file. We were editing our command history file. And at the beginning, I was talking about how using the debugger, we avoid editing files, right? Otherwise, we're adding print statements. And adding print statements means editing our source all over the place. And one reason that it's nice to use the debugger is not to edit the source, right? You take a program exactly as is. We've had a bug occasionally at work where a program runs and fails in a predictable way unless you add somewhere to it __end, and not somewhere at the end of the program. If you put __end__, the program behaves differently. And like, this is insane. Adding little tiny things that seem to have no effect to your program should have no effect. So going and adding a print statement, like, sure, it's innocuous, but it's changing the kind of buffer that's going on your standard out, and it's changing the number of lines that have gone into $. And like, everything's a mess in programming. So not touching the program is nice. But look, if we're going to edit stuff, we can edit stuff and make it better, right? We can edit our program and add things to our program to make it easier to debug when needed. So for example, we can take this program and we can stick into it this line, the one with the comment, that says, if x equals 10, set $db single to 1. Now, $db : single is normally not interesting at all. It's just some variable in a global namespace, and I guess you could use it for passing secret messages around, but normally it means nothing. But if you're running under the debugger, the Perl 5 DB debugger, setting that to true means I would like at this point to switch into single statement evaluation. In other words, that's a breakpoint. And you can put breakpoints into your program that basically say, if the debugger is active, this should be a breakpoint. So we can go and take this program, right? There it is with its breakpoint in place. When we hit continue, having done nothing inside of the debugger, it will break at that line for us. Now, it is up to you to decide how you want to abuse your programs by sticking these variables in them. But when you have problems that are known to exist, you could put something in here a lot more interesting than if x equals 10, right? You can say, if some unusual condition that happens rarely has occurred, this is the point, if the debugger is present, to make a breakpoint occur. And this is great when you have those bugs that only happen when you haven't prepared to see them, right? You prepare in advance, and then anytime you have the opportunity, the program will stop here and give you the ability to debug it. Okay, so that time it was a little underwhelming. I acknowledge that, right? It's just there's a variable, you can use it for stuff. There are a lot of other debugger variables that you can set. They let you change tracing. They let you change actions dynamically that are occurring. They let you plug into the event loop and kind of say, whenever this thing changes or happens, do something. I'm not going to show this to you because my experience is they have more bugs than the program that you are debugging. I find them very difficult to use, difficult to understand, and like I said, they're buggy. And the problem, of course, is that it's a debugger, right? And you can't debug the debugger with the debugger. So any bug you put into the debugger is there forever. This is the hard truth of debuggers. They never, ever get any better. Eventually, you just have to delete them. But I will show you some other things we can do. Pipe in front of any command will pipe it through your pager. This is more useful than you might expect, or maybe you expect it to be very useful. It is very useful. H will show you the history of all the commands you have run. I will tell you, I learned the hard way earlier this year that it does not include any single letter commands. And since single letter commands pull a lot of weight in the debugger, using this history is a little weird. You can use bang, just like in shell, to rerun a command, but it reruns it from that list that emitted all the single letter commands. So you can't just look back up and count how many it was. So again, limited use. I sent in a patch to fix this to Perl 5 porters, and it might go in, but that's a whole story. You can also make aliases, and these I will talk about a little bit. I don't use aliases a lot, but I use aliases when I'm debugging something that's going to take me a lot of time because they can save you a lot of effort. So I'm going to go back to my pseudo-random number generator. It's been really useful, and I want to refactor it to make the whole thing a sort of configurable system that'll last for 100 years. So what I do is I pull all the constants out, and I stick them into a place they can be examined outside of the enclosing subroutine. Right? This is pretty straightforward. There's some package variable, and the subroutine uses the package variable instead of having lexicals. So what's going to happen now? I run the debugger, and I'm going to switch over to the pseudo-random number generator file. And in here, I'm going to continue until we get to the random subroutine. And in here, we're now inside of random. I can say V, capital V, show me all the package variables. There's only one. Great. I'm going to continue to run the program until I get back into the main program. We see that's happened here. I've entered PRNG. And here I can say there's some lexicals. Y will show me those lexicals. Great. And at this point, I want to see those package variables again. So I'm going to type examine PRNG config. And right. So what's happened here is I get a list, right? Remember how we saw that much earlier? We get a list of things and it dumps them. This is a terrible way to view a hash. If I make it a reference, we get something much more useful. And like this is a line you could imagine me wanting to run over and over while debugging this program, right? If that's storing global state of the program and I have some way to say, show me the global state of the program, great. I want to run it all the time. So let's make an alias for that. And an alias might look like this. I'm going to say equals, make an alias, and I'm going to call it ZZ because that's cool. The alias is going to run examine a reference to PRNG config, right? So here's all the parts. Make an alias. The alias is called ZZ, and the alias is to this. So I run this, and then I try running ZZ, and I went back to having that stupid list form. Not fair. So let's look at this. I'm going to take this variable here, and how do I fix this? I guess there's a couple ways, right? I could I could add another back whack. Would that do it? Yeah, okay, that's great. I guess another option is maybe I could wrap this in squiggly braces. How'd that work? Ooh, not so good. Maybe it thinks it's a block. Okay, so I do this, ZZ. All right, so I've established two ways to do this, neither of which makes sense. One is up here. I can use a double back whack when I set up my my alias. Down here, I can put it inside of a plus squiggly brace. I don't know, right? Like, why did I have to do that? Let's just take a minute and talk about why you had to do that, because it's a fun anecdote. If I just run equals, it lists my aliases, right? It says ZZ is an alias for this thing, and that works. And when I had the version here that made sense, and I list it, that makes sense. What's the problem? Well, let's make another kind of alias first. I have an alias that I like to use. It's in my actual Perl DB, which I've disabled pieces of because I didn't want you to see all the stuff that I normally get. But I've got an alias here that instead of configuring at the command line of the debugger, I have generated for me every time I start it up. And it works like this. It says load data printer, and then set an alias called pp. And when you encounter somebody who's trying to use pp, use this substitution expression against the line that was put in at the terminal, which says, strip off pp from the beginning, throw that away, take the rest as $1 and pass it into data printer p without prototype scalar $. It's calling another pretty printer. Okay, that's what you need to know. So I'm going to come back here into this program. I'm going to redefine my alias in the way that I wish it would work. Whoa. Wow. Okay, that is not part of my demo. I have just somehow oomed my computer. Wow. Okay, live demos, everybody. Okay, that's fine. We don't need that. Here's what we're going to do instead. I'm going to load the program. Actually, the program's already loaded, and I'm just going to pretty print this variable. That's what you get if you just print it. That's what you get if you X it, the normal debugger built-in X. That's what you get if you use the pretty printer I've now stuck in. Another line you see in here I wanted to talk more about, and I'm just not going to have time, is something Curtis, who's on the call, pointed out to me. I've never seen this library before, but it's pretty nice. Use DB color. If I were to have had that when I was running this program, every time you list the program, you have it automatically syntax highlighted for you in these terrible, terrible colors that I'm sure I could configure somehow. I'm going to turn it off because I find the colors a little too off-putting and I haven't configured it yet. Okay. I'm a little bit bummed out that I didn't have time to, that I was not able, for this insane reason, to show you what's going on. Maybe I should stop talking about that because I think I have 2 minutes left. Is that right? And instead I'll move on with some other bits of the debugger. I'll tell you in chat later about the alias thing. It's great. Okay. Moose. So if you know my code, you know that this is probably how I actually would have written it. There would have been a Moose class called PRNG that has a bunch of member variables that define how the pseudo-random number generator is going to work. Then there'd be a role, and the role is like for a thing that keeps a log, and a thing that keeps a log has some of its own state and has a method to log a value. And then there'd be a pseudo-random number generator, and that itself would be a pseudo-random number generator that keeps a log. So it's pseudo-random number generator with log, and it applies advice to the random method saying, first, get the number, then log it, then return it, right? If you think this feels like some super overly engineered and enterprise-grade garbage, welcome to all the code that I write. If we take this program and we load that kind of number generator and we run with it, and we want to debug that program, you're going to encounter a problem. I'm going to show you the last couple things that you really need to see. Assuming I can load Moose with this apparently memory-constrained environment. Also, if you've been noticing on this beautiful 2020 era MacBook Pro how quickly the debugger loads, now we're going to load the debugger with Moose. So just pay attention from the sound of the enter until you see the prompt appear. I mean, there's a good 0.2 seconds there. Okay, so I've loaded this thing, and I'm going to use S to see all the subroutines that have been loaded in my program. It was a lot. If you pipe S, they're going to go to the pager. Here's all the subroutines that have been loaded by virtue of loading this monstrosity. How many of them? 2,480. How about all the modules? So big M tells you all the modules loaded in the program, and it also tells you their version. So for example, I've loaded autoloader.pm, which is version 5.74 from this file. Effectively what it's doing is it's dumping out key values where the keys are file names and the values are version from full path, which is possibly the worst format that could have been designed for you, but I mean, it's better than nothing, right? So fine. Here's our program, and we're going to continue on to line 15. That's where we call the pseudorandom number random routine. So we get here, and then we're going to, well, we can print the pseudorandom number generator, and that's garbage, right? We can examine it, and that's a little better. We can PP it, which is not so bad. That gives us some information, but it's missing a lot of stuff. We know that there are methods on here that we don't see. If we wanted to see all the methods, we can use M. M tells you all the methods on an object in the debugger. And this is the debugger command that I feel most people don't know about and should. It's kind of a pain, but it's really, really useful. There it is, right? Show me all the methods and where they came from. So we want to step into this code. And here we go. Step into it. What happened, right? We were expecting that we were going to step into maybe PRNG random or PRNG with log random, but we didn't get either of those, right? We got this monstrosity. And why did we get this monstrosity? It's because remember how we wrapped that subroutine in a method modifier? We said around. That thing is just like, look at it, right? We passed in an anonymous subroutine. And once you have anonymous subroutines, especially ones that are calling anonymous subroutines that are generated by named routines that call more anonymous subroutines, like everything gets real complicated. So that's where you want to know this one last thing, which is capital T. T shows you where you are in the stack of the program. What's your return stack? This is showing us the debugger is always here, right? Yeah, I could have stepped down a little further. The debugger is here, and then here is this thing with random log. And if I were to step down a little further into this, I've been told to shut up, so let's do it. If we quit this and we start over, we could say, show me the with log class. So here it is. And what we know is we want to continue on until, let's say line 12, where we're actually going to have a value and we log it. So we're going to put a breakpoint on line 12, and then we continue. And again, we've ended up in some anonymous subroutine. But when we look at the stack trace, we can see here's the debugger, which is inside of an around modifier, which is calling, being called from this subroutine. It's been politely given a name by Moose, which is being called because we called this. And in the leftmost column, what you see is the context in which everything has been called. As with many things in the Perl 5 debugger, the output is terrible. The means that by which you can use it are kind of a nightmare, but it is the most likely available tool to solve the problems you're going to have. And it can be wrangled to solve them. I think I have -3 minutes left and should probably stop just about now. So I'm going to flip through a bunch of these slides. I'll put these slides online somewhere. Yeah, there's help. Here's a bunch more stuff I didn't talk about. There is help in the debugger. The help is terrible. Don't bother. There's also, there's a book. This book by Andy Lester and Richard Foley is, it's the best book you're going to find on the topic. It's not the best book about Perl, but it answers a lot of questions about the debugger. Okay, that's it. I should stop there. There's actually a lot more, but like I said, I always run over, and that's how life is. I'm happy to take questions until they tell me to stop, which they might as soon as I finish this sentence.
We have 1 minute, so we can take one question.
Who has the best question?
Where is your stuff online?
It is not online yet, but I will put it online, and I will say on Slack where and when it has gone online before the end of the business day.
Not a great speech. Thank you so much.
All right. Thanks, everybody.
Thanks, Rick.
Ciao.